Swayam Prabha. Digital India. Educated India.
After that, learner will be able to understand method of preparation and reactions of aromatic amine. Learner will be able to understand various uses of aryl diazonium salt. So it is one of an example of an aromatic amine, and it is utilized for lot many purposes in synthetic chemistry. So let's see the contents of this session. So firstly, we will see introduction to aromatic amines and basicity of aromatic amines. After that, we will see effects of substituent on basicity and some resonance structure. So effect, there are two types. One is electron withdrawing effect and second one is electron donating effect. After that, we will see preparation methods of aromatic amine. So various ways to prepare an aromatic amines. After that, reactions of aromatic amine. And lastly, we will see synthetic uses of aryl diazonium salt. Aromatic amines. So let's see the introduction part. So amines, basically, you might be knowing that aliphatic amines are and straight chain compounds, or we can say aromatic amine differs from an aliphatic that it contains an aromatic ring. So this course almost it contains aromatic structures in your syllabus, and in that we are looking to an aromatic amines now. So aromatic ring adjoined with an amines are said to be an aromatic amines. So these are the derivatives of aromatic hydrocarbons in which hydrogen of an benzene ring has been replaced by an amino group. So simply replacing an hydrogen or by substitution of an hydrogen atom of an benzene ring by an amino group. So this kind of an example it is of an amine, aromatic amine. The compound it is aniline having only one amino group, and it has been substituted by two more hydrogens, and that is why it is said to be an primary amine. So aromatic amines basically they can be categorized as an primary, secondary and tertiary. So already we have seen an example of an primary amine. Absorb and UV spectra, and that is why it is showing an and the aniline actually benzenes are colorless, but aniline it is not an colorless compound. It is almost a little bit yellow in color, and this yellow in color or yellow color of an aniline it is due to an chromophoric group present on it. So chromophoric here the group chromophore that is an amino group, so which makes that aromatic ring colorful, and due to which it has an color. And all the color compounds they have and absorptions in the region of an UV visible spectra, and that is why it shows and spectra or absorption spectra UV region. And apart from that, conjugation in aromatic ring is also responsible for an absorption of an spectra, because here there can be seen two types of an transition. So one is N to a sigma star, that is due to an aniline, and pi to pi star transition, it is due to an aromatic ring. And aromatic ring means a double bond between an aromatic ring. So both this transition leads to an absorption UV region. After that, in IR spectra, so from IR spectra, one can understand that when it is showing and bands in 650 to 900, so it has been substituted. Apart from that substitution, this stretch, it is of an aromatic stretch of 650 to 900, and 1500 to 1640, it is due to an aromatic stretch, as well as an carbon-carbon, it is due to an carbon-carbon double bond present in an aromatic ring. Also, it gives and spectra in the region of 3400, and especially because when it comes to an tertiary, primary, and secondary, so all these are having a different spectra in 3400, in the region of 3400 to 3000 almost centimeter inverse. But primary, secondary, they will give a different thing, while tertiary will give a different thing. A different thing means spectra, it splits over there, and whenever there is medium type of and sharp type of an absorption, so it is indicative in 3400, it is an primary amine basically. And in case of an NMR, here it is not given actually, the NMR spectra. In case of an NMR spectra, the aromatic ring, it will show in the region of almost 7, means from 6.5 delta values to 8.5 delta values. And this amino group, so it gives in a region around 3.5. Above 3.5, it does give the region, so it will give an singlet as well as an aromatic ring. So at now we'll see some compounds, what So what extent of an basicity does they have? So we will see and their values of an basicity. So the values, it is been denoted by Kb, that is base measurement for an basicity of an compound, or strength of an basicity of an compound, that is Kb. So the first structure, that is methylamine. So simple aliphatic compound having a value Kb 4.4 into 10 raised to minus 4. After that, aniline. So whatever we are seeing now in this session, that is aromatic amine, having a value of basicity, that is 4.2 into 10 raised to minus 10. After that, paratolidine, having an substitution at an para position of an CS3. The value of Kb, that is 2 into 10 raised to minus 9. And after that, orthonitroaniline. So replacement of an nitro group at an ortho position. Replacement of an hydrogen by this nitro group. And the value, it is 5 into 10 raised to minus 15. So from this table, we can see that aliphatic amine, they are having quite higher values, and there are some reason behind it why it is having quite higher values. So we'll see what are the reasons actually after the resonating structures. Now we'll come towards an resonating structures of an aromatic amine. So we have taken one of an example of an aromatic amine, and based on that we will be discussing. In aromatic amines, a non-bonding electron pair is delocalized into a benzene ring by resonance. Hence aromatic amine are least basic than aliphatic amines, which does not show resonance, because there is no need for an aliphatic compound to show an resonance, as there is no delocalization of an electron pair. Here it is having an space for delocalization of an electron pair in the benzene ring. So that is why electron pair can be delocalized. And in case of an aliphatic, and that is why aromatic amines are least basic, because the charge, it has been distributed or it has been dispersed in a hybrid structure. And in case of an aliphatic amine, there is no resonance or charge cannot be delocalized, and that is why this aliphatic amine remains as a stronger or more basic compound than an aromatic amines. And beyond that, so whenever it comes to an basicity, so basic compounds are such compounds that they do have an negative charges on them. Higher the negative charge, more will be the basic compound, and they has an ability to donate an electrons. So here we have taken an example of an aniline. So aniline, it is having and lone pair on a nitrogen, and this non-bonding lone pair of a nitrogen, it will shift and it will create a resonance in the structure. So non-bonding electron on a nitrogen, now it will shift the electron towards carbon and nitrogen, and now it will form a double bond between this nitrogen and carbon. As soon as the bond, it has been formed between the carbon and nitrogen, the pi bond between ortho carbon and this first carbon, it will break. And pi bond, it is easy to break, so that is the reason why it breaks, and the sigma does not break. And all the time you will find that whenever there is a resonance in case of an aromatic ring, so there will be a delocalization of an electron with the help of this pi electrons or breaking of an pi bonds between carbon and carbon. So double head arrow, it indicates an resonating structure. Now it can be seen that this nitrogen, it has been formed an electron deficient center having an positive charge on it, and pi bond it has been formed, and shifting of an now pi bond towards an ortho carbon. Now it is having a negative charge. A negative charge carbon, it will again shift an electron towards a further carbon, and it will break the pi bond between meta carbon and para carbon. So this cycle will continue. After that, again the double head arrow showing and resonating structure. So now you can see there is formation of one more new bond over here, and this new bond, it is formed because electrons are being shifted newly between ortho and meta carbon, and the para carbon, it is having a negative charge because electrons were being shifted on the para carbon, so it is now having a negative charge. As soon as the para electrons, or the not para electrons but it contains a non-bonding electron pair. In case of a nitrogen, we can see only one non-bonding electron pair. In case of an oxygen, we can see two non-bonding pair of an electron, and further on an halogen, we can see three non-bonding pair of an electron, and later on it becomes an octet, and noble gas element starts from over there. But now in case of an nitrogen, we can have a nitrogen has a non-bonding electron pair, and this non-bonding electron pair, it is responsible for an electron distribution on a benzene ring. And if we see the structure of an hybrid, so the non-bonding electron pair of a nitrogen, it will disperse that non-bonding electron and benzene ring and is less available for an protonation. So here we can see it. Or nitrogen having one lone pair of an electron which is non-bonding, and it will be dispersed into an benzene ring. And for resonating structure shown double head arrow, and now this, so it can be understood by this way that non-bonding electron pair, it has been dispersed, and now it is forming and partial bonds in between, and the pi bonds which are in the ring, so all they are equivalent, but now the charge it is been distributed. And also from this one can understand why that amino groups, when it comes to an aromatic amines, they are ortho paradirectic, because whenever we come across an aromatic electrophilic substitution, all the time there is aromatic electrophilic substitution only in case of an aromatic substitution. So electrophile which has an positive charges, so they will come at ortho position, because partially here you can see whenever the charge it has been distributed or been dispersed, or electrons are been dispersed by a nitrogen atom in the ring. So ortho positions and para position, they will have an negative charges, while adjacent to that instantly they should have an positive charges. Means meta should have an positive charges. So that is why all the time there will be an ortho para product. And this resonance hybrid, in case of a resonance hybrid, now electron density is less on nitrogen, because whatever the electrons they were been present, so they are been given into the ring, and that is why the electron density has been reduced on a nitrogen. We will come to one of an example, that is diphenylamine. So diphenyl name itself indicate that it is having two phenyl ring, and in between it is having an amine. So such kind of a structure it is having. Now we'll learn about and basicity of this diphenylamine. So one of an example I have taken. So from this it can be understood that why primary amines and secondary amines and tertiary amines, why they are weaker in the series. Means tertiary are more weaker than secondary and then primary. Means primary are most strongest bases compared to an tertiary in the series. And why it happens actually? So from this structure you can see that there are two phenyl rings to adjacent of a nitrogen, and diphenylamine is weaker base than aniline. So when it comes to an aniline, here it will be no phenyl ring, it will have an hydrogen over here, and now it is having one more phenyl ring, and these phenyl rings, they are negatively charged, or they will abstract an electron from a nitrogen atom and making less density on a nitrogen atom. So whatever we have seen in case of a resonance hybrid of an aniline, so it has a little bit more density of an electron on nitrogen, but here as there are two rings, so charge will be dispersed on the two rings, or it will be abstracted, the electrons will be abstracted from a nitrogen by both the rings equivalently, and that is why there is less number of an electrons, or we can say there is less density of an electrons available on nitrogen atom, and due to which the reason diphenylamines are weaker bases than anilines. And non-bonding electron pair on nitrogen is still less available and distributed over two phenyl ring, because phenyl ring, when it comes to a phenyl ring, so phenyl ring has a character that it is an electron withdrawing substituent, so it will withdraw an electron and will decrease the basicity of this nitrogen, as there is a less lone pair of an electron available for unbonding. Now we'll see the next point, that is effects of substituents on basicity. So there are two types of substituents. One is electron withdrawing and second one is electron donating type of groups. So what kind of an effect does they show on basicity of an aromatic amines? So we'll see. So first one, that is electron withdrawing effect. So electron withdrawing group such as nitro, chloro, cyano, aldehyde, carboxylic acid on the ring lowers the electron density on nitrogen atom, making the electron pair less available for protonation. So the example like orthonitroaniline is even more weakly basic than aniline. So this is structure of an aniline and this one is structure of an orthonitroaniline. So electron withdrawing group, it withdraws an electron from an ring and which lowers an electron density on a nitrogen atom, making the electron pair less available for protonation, and due to which the electronegativity of an nitrogen atom becomes less, and such kind of an groups, such as we have taken an example, that is nitroaniline is weakly basic than an aniline. So electron withdrawing groups, they lowers the basicity of an aromatic amines. When the basicity it decreases, it means that the electron withdrawing capacity of an adjacent group or whatever the substituted group, so it is having an electron withdrawing effect, and due to which basicity it decreases. So compound to be more basic, it should have a negative charge, and once the electrons they are been abstracted by an substituent, it means that the negative charge on the primary, or we can say an aniline, it decreases, and due to which its basic character decreases. By tin. So in case of a benzene and its derivative, we have seen how to synthesize a nitrobenzene. So nitrobenzene, it has been synthesized by benzene and nitrating mixture, that is concentrated HNO3 and H2SO4, and after that benzene ring, it has been substituted by a nitro group, and when nitrobenzene, it has been reduced, and this reduction, it is mainly done with tin and HCl, and there are some kinds of reduction like this nitro group can be also reduced by some other ways, so we will look what are the other ways also. And this nitro group, it has been reduced, so reduce, it means oxygen is been removed and hydrogen, it has been added. So reduction, it mainly, it means that addition of an hydrogen or removal of an oxygen. So these both terms can be utilized for an reduction. So this is how aniline can be prepared. Way of preparation of an aromatic amine, that is Hoffman degradation of an amides. So one of an rearrangement, that is Hoffman rearrangement. By this kind, we can prepare an amine from an amide. Heating of an aromatic amides with a mixture of bromine and alkali such as KOH or NOH forms an aromatic amine. So this is a structure of an benzamide, and when benzamide is, it is been heated with bromine and alkali, that is NOH, it forms an aniline. Now from this, it can be seen that this Hoffman degradation is such kind of an degradation. Why it is said to be an degradation and why it is not said to be an reduction justly? Because in case of an Hoffman degradation, you can see that one carbon, it becomes less in the end product, and that is why it is said to be an degradation. And amide, it has been degraded to an amine, but having one carbon less, right? And this carbon, it forms an CO2, and indication of this reaction, it can be understood with the help of removal of an CO2 from an reaction, or the end point of an reaction can be understood when removal of an CO2 has been finished. So CO2 has been finished, it means that CO2 or this benzamide, it is converted to an aniline with the removal of this and CO and one O from this NOH. Aniline or this cyano, it has been removed, and aniline or an amino group over here it has been formed, or either it can be also reduced by an lithium aluminum hydride. So hydride, it means H minus type of an molecule or atom. It has been given away by this lithium aluminum, and due to which cyano or nitrile it has been reduced, and it. Next way to prepare an aromatic amine, that is reduction of an amides. So it is different from an Hoffman degradation. Amides are reduced by lithium aluminum hydride to yield amines. This is structure of an benzamide and lithium aluminum hydride, and it forms an benzylamine. So why it is different from an degradation of an Hoffman? In case of an Hoffman benzamide, it is been utilized, but the end product it is aniline. But here the end product it is an benzylamine. A carbon it has been written. In that case, a carbon it has been reduced. Carbon it has been removed, and instead of that, only amine group it remains at this first position. In this case, and this is a special type of an reduction where we can see an hydride ions. So this H minus ions are called hydride ions, and it is having a metal adjacent to it, and it is a strong metal. Aluminum it is a strong metal. That is why it is giving an minus hydride minus ions, H minus ion, and it can reduce this carbonyl. See, if we can see that carbon it is having an electronegative atom, that is oxygen, and oxygen it will always have a negative charge. It is actually a double bonded oxygen having a pi bond in between and one sigma bond. So all the time it will happen that oxygen it is an electronegative, and this will carry a negative charge while carbon will have a positive charge. So exact what this lithium aluminum hydride does, so it gives a negative type of an hydrogen which interact or which gives an electron towards an carbon and makes this electron deficient carbon electron rich. And afterwards, or it satisfies the valency of an carbon, and afterwards the oxygen from this carbon it is been removed, and it forms an benzylamine. Next method, preparation of an aromatic amines, that is from chlorobenzene. When chlorobenzene is heated with ammonia in presence of copper chloride, yields aniline, and it has been heated again in a high pressure reaction vessel at 220 degrees Celsius. So copper chloride it act as an just an intermediator or catalyst, and one more substance here it has been remaining, that is ammonia. A reaction it is carried away, carried in an ammonia in presence of an ammonia. So copper chloride it just acts as an intermediate or an catalyst, and after that aniline it has been formed. So ammonia it has been utilized in this reaction. After that, reactions of an aromatic amines. So the first reaction of an aromatic amines we will see, that is reaction with an acid chlorides. So when it has been reacted with H3PO2, it forms an benzene. When it is reacted with copper chloride, it forms an aryl chloride. Alkyl, it has been substituted, or alkyl, it has been replaced in place of this N2, and not alkyl, sorry, halide. Halide, it has been replaced. So here you can see the chlorine, it has been replaced, forming an nitrogen and copper chloride or copper halide. No properties, they are mainly used starting material for an azo-dyes. So dyes are in such compounds which are colorful in nature, and amino group, it is responsible, as we have discussed, that it is an chromophoric in nature. It imparts an color to an compound, and due to which So there are three categories mainly: primary, secondary and tertiary. So the meaning of primary, it means that there are two hydrogens remaining on a nitrogen and one it has been substituted. And secondary, it means two hydrogens, they are been replaced and having some functional group around. And tertiary means all the three hydrogens, they are been replaced in the nitrogen and it is surrounded within some functional group. After that, we see the concept of basicity, that amines are basic in nature and it is due to its ability to accept a proton. Aliphatic amines are more basic than aromatic amines. So the reason behind this, it is that aliphatic amine, it does not have an resonating structures, and in case of an aromatic amines, the electron, a pair of electron which is present on an amine or nitrogen, it has been delocalized into an benzene ring, and that is why there is less availability of an electron density, or electron density of a nitrogen, it decreases, because aliphatic amine, it contains an electrons all the time with it. After that, we seen that diphenylamines are less basic than aniline because it has two phenyl rings which shows electron withdrawing character. After we have seen there are two categories, that is electron withdrawing group which decreases the basicity, while electron donating group increases the basicity. After that, we have seen preparation of an aromatic amine. So there are 5 methods that we have seen in this session. So firstly, that is reduction with tin and HCl by using nitrobenzene. After that, benzamide. So benzamide, bromine, with the help of an bromine and NaOH. So such kind of a reaction, it is said to be an Hoffman degradation. After that, we have seen that benzonitrile. So it has been reduced with the help of H2 gas and nickel or lithium aluminium hydrate. After that, we have seen an benzamide. So exactly that is not a structure that is been forming from an benzamide. So it is CH2NH2, not an aniline. But here it is shown that after reducing, we get an aromatic amine from it. Carbon has been reduced. After that, we seen that chlorobenzene, it has been replaced by NH2, and this reaction, it is carried at high temperature 220 degrees Celsius with the help of copper chloride. After that, we seen the reactions of an aniline. So aniline, when reacted with acid, chlorine by using copper chloride, and for bromine, it can be done by using copper bromide, forming aryl bromide as a product. After that, using copper cyanide, giving cyanide as a product, or aryl nitrile as a product. After that, disonium, it is replaced by an halogen like an iodine with the help of an potassium iodide. After that, disonium, it is replaced with OH, that is forming an phenol with the help of H2SO4 and H2O when it has been heated, and after that hydrofluoroboric acid forming an aryl fluoride when it is diazonium salt it has been heated. So these are some synthetic uses of an aryl diazonium salt, and along with this we have seen the uses of an aromatic amines. So aromatic amines act as a precursor for lot many pharmaceuticals. Also they are utilized as an pesticides, and they also have as an antioxidant properties.